Hi. Then
Hello.
Jocelin Burnell, the full name, right?
Yes.
So I call you Jocelin.
Please.
Jocelin.
Yes.
Yes. How often do you come to Thailand?
I've been on 2 trips before this.
Yes.
This is my 3rd one
Yes.
in maybe 20 years.
Wow. What is your association with Thailand?
I know the astronomers who work at NARIT.
Yes.
I also have contacts, of course, with the British Embassy in Bangkok.
I see. So this time you talked to the inauguration of the astrophysics, the Jocelin Astrophysics Park, right here?
Yes, yes, that's right. Yes, I addressed the princess.
Yes, I was there. Very exciting.
It was very exciting.
How did you feel before the princess? She's very interested in astronomy.
Yes, she is. I was surprised and delighted how interested she was. She was taking notes,
Yes.
which I find amazing. Yeah.
Yes, yes.
Brilliant.
Yes.
Yeah. Yes.
Astronomy in the world today, how do you feel about its role, its importance, and how is Thailand related to the scene of astronomy around the world, the global scenario?
Yes. Astronomy is one of the major sciences. It's recognized not only for what it tells us about the universe and how we came to be, but it's recognized also because it makes quite strong technological developments necessary. So it drives technology. In the world, Thailand is growing in importance. Thailand is building many links, many partnerships, and I see it getting stronger and stronger and playing a bigger and bigger role, which is wonderful.
You've met many astronomers in Thailand here.
Yes, I have, yes.
Are they up to the world standard?
Yes.
Yes?
Yes.
Definitely, yes.
Yes.
Yes. What role can they play in the global system?
There's lots of different ways of doing astronomy, and one of the important things is to do it as many different ways as possible. So Thailand is building links with other Southeast Asian countries.
Yes.
And developing networks there, which is very important. There's not been so much astronomy in Southeast Asia, so it's good to see it growing.
A very common question from the Thai people, and I believe also around the world from the general public. What is the point of spending money on looking at the stars in the sky? And I'm sure you get this question all the time. How do you explain this to the general public about the importance of astronomy, usually when you, and in simple language too?
Yes, yeah. Well, I believe it's important that we understand our place in the universe.
Yes.
It sets some of our earthly things in a useful context. But astronomy is one of the forefront physical sciences. It's employing major computing, major instrument development, for example. And people who train as astronomers have very useful skills and go out into the technical world and work there very successfully. And the astronomy itself needs better and better equipment, better computers, better data transmission systems, better cooling of instruments, more sensitive instruments. Machine learning is something that we're just beginning to get into. So a lot of very modern techniques are used in astronomy and developed in astronomy.
You yourself, how did you get interested in astronomy?
I got interested when I was about age 14 or 15.
Yes.
I read my father's library book. It was by Fred Hoyle, a famous British astronomer,
Yes.
and he wrote very well for the public. So I very much enjoyed this book, and I could see that the physics I was learning at school was being applied in astronomy. So I thought, right, I can be an astronomer.
Did your father encourage you to do it?
Oh, I was much encouraged, yes.
Yes?
Yes. Yeah.
So you got started early and you were interested, and how did you pursue your interest?
I did a physics undergraduate degree because that gave me a good general physics education.
Yes.
I was aware that I might not succeed in becoming an astronomer.
Why not? Why not?
Well, it's quite hard to do, and there weren't many women, and various issues
at that time. Right.
At that time, yes. So I thought if I do a physics degree, I can get a good job.
Yes.
If I cannot be an astronomer.
Right.
But my first choice would to be an astronomer.
And you succeeded.
And I succeeded, yes.
So it wasn't that difficult after all for you, right?
It was quite hard work.
Hard work?
Yeah.
In what way?
Some of it was physical hard work.
Right.
We had to build our own telescope.
Yes.
So we were hammering stakes into the ground and stringing up cables between the poles. And,
right.
My job was all the connectors and transformers.
Yes.
And there was a lot of it because it was a big radio telescope.
Did you have friends who share your interests and help one another to...
There were a group of graduate students. We were all housed in the attic, up in the roof.
Right,
yeah.
because that's the closest to the sky, right?
13 of us.
13. Oh, 13.
Yes.
Mostly boys.
Oh, yes, I was the only female there.
Oh, really?
Yes.
The only female?
Yes.
Yeah. So?
But that was a useful community. The students supported each other, which was good. Yes.
And then, of course, you went ahead and did your PhD in astronomy.
In radio astronomy.
In radio astronomy.
Yes, that's right.
Can you explain to the common people what radio astronomy is and what is astronomy itself?
Right.
Why radio astronomy and why just astronomy?
Well, these days astronomy is done in a whole lot of different ways.
Yes.
Traditionally, we were picking up light from stars and planets and galaxies.
Yes.
But today we can also pick up radio waves or X-rays or infrared or millimeter or ultraviolet or gamma rays.
Yes.
And very recently a whole new kind of radiation called gravitational radiation.
Yes.
So astronomy is now done with all those different ways, and they complement each other. They help our understanding of what the thing we are looking at is, because we can view it, so to speak, from different angles with the different kinds of astronomy and get different bits of information. So increasingly people are not just a radio astronomer or just an X-ray astronomer. You work over a range to help you understand why that star is behaving the way it is, or why that galaxy is doing what it appears to be doing.
So when you talk about radio astronomy, it is specific to radio.
It's radio frequencies.
Radio frequencies.
Yes.
But of course, as an astronomer, you would have to work with radio frequencies anyway.
Yes. Some people manage to avoid radio but do everything else.
Yes.
Some people do radio and not much else.
Yes. Right.
And so on. Yeah.
In Britain, how is astronomy considered?
The public are very, very interested.
Yes.
Some of the astronomers are some of the most able scientists in the world.
Yes.
So it's seen as an important subject, even though it's not immediately useful in the sense it doesn't make drugs or it doesn't do things like that. But it's a fundamental science, and the more we understand about the universe, the better we will be able to live in it.
You get more younger people interested?
Yes.
Yes.
Small children are very interested in astronomy.
Yes.
I expect they find the same thing here in the planetarium.
That's true, yes. We notice that a lot of young students come here and get inspired by these new facilities.
And some of the youngsters know a lot. They know all the planets and all the moons of all the planets.
Yes, they don't have to memorize them. It just happens.
It sticks,
It sticks, right?
Yeah.
Because of the curiosity.
Yes.
And the interest in something out there, right?
Yes, outside the Earth.
Outside the Earth, right.
Yes, yes.
So you were one of the pioneers in discovering pulsar, so-called pulsar.
Yes.
How did that happen? Can you tell us again? I know you have answered this question many, many times. But for the Thai audience, maybe.
Yeah. Excuse me.
Yes.
Just let me
Go ahead.
take it.
Yes.
So it really happened by accident.
Uh-huh.
I, to my surprise, had a place in Cambridge University,
Yes.
which was considered the top university in the country.
Yes.
And I go to Cambridge and everybody is very, very clever.
Yeah.
Oh.
Were you scared?
Yes, I was scared. They have made a mistake. I'm not clever enough to be here. They will find out and they will send me home.
Oh, you were really afraid of that?
Really afraid. So I had a policy. I decided I would work my very hardest,
Yes.
so that I'd work my very hardest until they sent me home.
Until they discovered that I wasn't
That's
smart
right.
enough.
Yeah, and then I would not have a guilty conscience when I was sent out. I'd known I'd done my best.
Okay.
So I was working very, very hard, being very thorough,
Yes.
and spotted a tiny, tiny signal
Yes.
that didn't make sense, that was an anomaly,
Yeah.
and followed it up, and it disappeared and came back,
Yes.
and it turned out to be pulse, 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 pulse.
That was no noise, of course. You couldn't hear anything, of course. You see just the light, right? What do you see?
Radio wave.
Radio wave.
Radio wave,
Radio
yes. So if you listen with headphones, you'd hear blip, blip,
Oh, you hear
blip.
that?
You
I
could
see.
do, yes.
Can you see anything?
No, you don't
No.
see with radio waves.
Nothing. You just hear it.
Yeah.
So you spot
Well, it comes out on a chart.
Okay,
so
all right, the chart. Okay.
The pen,
So
yes.
it's blip, 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 and
yes.
boop, boop, boop. It's like our pulse.
A bit like a pulse, yes. It would. Yes.
So what was the first impression?
Well, my supervisor was sure it was interference,
Interference.
because radio telescopes are big.
Yeah.
They pick up very weak signals.
Yeah.
Today, mobile phones,
Yes.
taxi radios,
Yes.
plane altimeters,
Yes.
broadcasts,
Right.
they all cause radio interference.
Yes.
There's meant to be some bands that are kept clear for radio astronomy,
Yes.
but even so they kind of,
They can just interfere with you.
Yes. So my supervisor was quite certain it was interference.
So say you didn't give up. I said, okay, it's just interference.
No, because you know the stars come round every 23 hours, 56 minutes.
Yes.
The constellations in the night sky in summer
Yes.
are different from the constellations in the night sky in winter,
Yes.
because the stars come 4 minutes earlier each day.
Yes, I see.
When this signal was present, it often was not, but when it was present, it was coming 4 minutes earlier each day.
4 minutes earlier each day.
So-
you watched and you kept the vigilance.
So that really suggests it's something that's moving with the stars. It's keeping its place amongst the stars.
So that's why you were beginning to argue with your supervisor.
I was not convinced by his rapid decision that it was man-made interference.
Right. Okay. So you kept watching.
I kept going, yes. And it was a puzzle, but then I found a second one. And that was great. And fairly soon thereafter, a third and a fourth, all in different parts of the sky.
Different parts. So
So-
they came from different sources.
Yes,
Okay.
yes. And it's not little green men signalling to us, because there aren't 4 lots of little green men.
How not possible.
Well, especially using a stupid technique.
Yeah. Why stupid?
If you want to communicate by radio, FM, frequency modulation,
Yes.
is much better than amplitude
Yes.
modulation.
Yes. FM.
This was not frequency modulated.
No.
The pulse period, the frequency kept very, very, very steady. So if there was any signal there, it was amplitude, the height of the pulses. And that's a crazy way to signal,
communicate.
because there's so many ways that the amplitude can change naturally. It's an unreliable way of communicating. So they weren't very intelligent little green men.
No.
4 lots of stupid little green men?
No, not possible.
Not possible.
No.
No.
But who thought about little green men?
Unfortunately, I nicknamed this.
You did?
I did. LGM
Why did you?
for little green. Well, you had to call it something.
Something. But little green men came to your head when You started to think
Well,
maybe
only as a joke.
only as a joke.
It was a joke, but I now regret it because it's stuck.
But there was no suspicion in your mind at all that it could be little green men, that it could be aliens sending?
Not once I'd found the second and the third and the
at
fourth.
first, the first one, yes, you were
The first one was
uncertain.
about 2 weeks before I found the second one.
Ah, I see. So once you found the second one and the third one, the period between the second and third and the fourth,
Yeah.
2 days, 1 day, how many hours?
The first one was at the end of November. The second one was about 3 weeks later.
3 weeks.
And numbers 3 and 4 came together about 2 weeks after that.
Oh.
So we're talking 6, 7 weeks.
6, 7 weeks.
Something like that.
But on a reasonably regular basis, right? Once you hear it the rhythm, the pulse
Yes.
was quite regular. It's not
Yes.
not interference, meaning it could beep now and beep and then it goes quiet.
Well, yes, it does, because it's a very weak signal,
Very weak.
and you only pick up the strongest pulses.
I see.
And we also had a problem with scintillation. Material between the stars
Yes.
sometimes caused the signal to fade for a week, 10 days, and then it would come back up again and I could see it.
I see.
But there were gaps where I could not see it.
But then after you heard from four different sources, what was your, not conclusion, what was your speculation?
Tony, my supervisor, was convinced it was the then most dense type of star known, called a white dwarf. He thought it probably was a white dwarf, and he thought maybe there were shocks going out through the atmosphere.
Yes.
Going blup, blup,
Right,
blup,
right.
blup.
Yes.
He had worked on bursts from the sun, and the sun does blip, blip, blip,
yes,
blip.
Yes.
So he thought it might be an oscillating white dwarf that is launching blip, blip, blip,
right,
blip.
Right.
The alternative picture is something spinning. And it's interesting, when something spinning gets tired, it slows and stops.
Stops, yes.
Whereas if something vibrating gets tired, it quivers faster and faster and faster
Oh, yeah.
and stops. But it was maybe 6 months later before they found the pulsar in the Crab Nebula.
Yes.
They were able to see that it was not doing this.
No.
It was getting slower.
Slower.
So it's something rotating.
Something rotating.
So for the first 6 months we were unclear whether it was vibration or rotation.
And then once after 6 months, you more or less concluded it was rotating.
Yes.
And
Yes.
then what did that mean to you as an astronomer?
Well, it meant it had to be a new kind of star. If it had been vibrating, it was probably a white dwarf star, which we already knew about. But if it's rotating, it's something much more compact.
Right.
Maybe the same sort of mass, maybe a bit heavier, but much, much more compact. And so it turned out to be these stars that have a mass like our sun, but only a radius of 10 kilometers.
Small.
Very small. Yeah.
And it spins around itself.
Yes.
And it sends out.
It's, you know, here on Earth there is the North Pole where the globe turns.
Yes.
There's also magnetic field, magnetic north, magnetic south.
Yes.
Similarly, on one of these pulsars there's the pole where it spins,
Yes.
and there's the magnetic axis which is inclined, so the spin, and so you see the magnetic axis come round.
Yes.
And you see pulse, pulse, pulse each time you see the magnetic pole of the star. So that's the picture we have now.
So how long did it take you and your supervisor and the whole team to decide this is what we call pulsar?
The name pulsar
Yes.
was invented by a newspaper correspondent,
Oh, really?
the science correspondent of a rather right-wing newspaper in Britain. He said, "What are you going to call these things?"
Right.
And
And what did you call it in the beginning?
we called it a pulsating
Pulsating star.
star. Pulsating radio
Pulsating.
star,
Ah,
yes.
Okay.
We had had a long discussion about whether it was pulsating or pulsed.
Pulsed, meaning
But pulsed might mean there was some agency, some little green men
yes, yes.
making the pulses.
Right, right.
So we went for pulsating.
Pulsating.
So he said, this correspondent, what are you going to call it? We said, pulsating radio star.
Pulsating
He said,
radio
no. Something short.
Something short.
What about pulsar?
Pulsar.
So this journalist invented the name.
Oh, so did he consult you?
Well, it was in the discussion with us.
Oh, really?
And then he wrote it in the newspaper.
Oh, and then that stuck.
That stuck, yes. Yep.
Are you happy with that, pulsar?
I think it's good, yes.
It's good. And
Yes.
now it is a common term, pulsar.
It is, absolutely, yes. It's the name for them.
Yes.
Yeah.
And then, of course, the Nobel Prize Committee decided to give the Nobel Prize for Physics. 1974?
4 or 5.
1974, 5?
I can't remember which, but yes, around there.
Yeah, officially it's 74.
Right.
Yes.
Okay, I take your word for it.
And your name wasn't there.
No.
Right. And it's still a story today, even up to now. How do you feel about that?
I was actually very pleased about the award of that Nobel Prize.
Sure, yes.
There's no astronomy prize,
No.
and until then, very few, maybe only one astronomer had had the physics prize,
I see.
and that was long ago. So I recognise that the Nobel Committee awarding the physics prize
Yes.
to pulsar discovery creates a precedent,
Yes.
and that many more astronomers will get
Ah,
the physics prize.
right.
And I was right, because by now maybe 20 astronomers have had the Nobel Physics Prize.
So that set the precedent.
That set the precedent. So, you know, this last time, 3 astronomers.
Sure, right, right.
Yeah.
Yes.
So it was an important step for astronomy and astronomers, and I was pleased that our stars had convinced the Nobel Committee that there's good physics in astrophysics.
But a lot of people say, why not Jocelin? Why wasn't she there? Included
Well, they don't always notice students, because I was only a student.
on a student. But when it was, the committee had to consider nominations, right?
Yes.
Who was the nominator?
I don't know, and I don't think we will know until they open the papers
Right.
50 years later.
Right.
So I don't know.
So you didn't feel bad about not being
No,
one of the recipients?
But I've actually done, I think, even better through not getting
I
the
know.
Nobel Prize.
I know. I told somebody that maybe the fact that she didn't get it makes her more famous than getting it.
Yes, and you get every other prize.
Yeah, that's true. So
Whereas if you get a Nobel Prize, it's so terrific, nobody can match it. So they say, no,
so
no,
that's
no.
the end of it, right?
That's the end of it, yes. One party, finish.
Yeah, so this is better.
Much better,
And
yes.
since then, you have been, awarded all kind of
Yes.
prizes and all
Yes,
this.
yes.
So it makes your life very colorful.
That's
and-
right, it's fantastic, yes.
And what have all the prizes done to you?
Well, they've given me the opportunity to travel like this,
Yes,
which I very much enjoy.
Yes.
Been fantastic coming to Thailand.
Yes.
Particularly in January.
January, which is very cold
In Britain, it's miserable,
Britain.
yes.
Where do you live? Where's home?
I work in Oxford.
Oxford is
Yeah.
cold in winter. Very
Yeah, it's a bit damp. There's a river.
damp. Huh?
Yes.
Damp.
Damp and cold.
Damp.
Yes.
And of course, it gives you also opportunities to engage with a lot of people around the world.
Yes,
right?
it does. Huge privilege, yes.
With
Yeah.
the latest prize, I read in the newspaper or online that you donated the whole sum of the prize to a fund or research fund, right?
Yes.
What was that prize about?
Well, I argue that the reason I discovered pulsars was because I was being so very thorough. And I was being very thorough
Yeah.
because I thought they would throw me out.
Yes.
I was different from everybody else. I was female.
Yes.
I came from up north.
Yes.
And so
Minority.
Minority, yes. And so I argue that if there are more minorities,
Yes.
I think science will be healthier.
Yes.
So this money is going for minority students who want to do research in physics.
Wow, wow. So you want people who might otherwise have no opportunities to do
Yeah.
it, to have that opportunity.
Yes.
But it was a lot of money, 2.3 million pounds?
Yeah, $3 million
$3
was
million?
how it started,
Yes.
yes. Yes.
So you give away the whole amount? No.
Yes.
Oh, wow. And how do you run it? How do you manage?
I don't run it.
You don't?
Once you give away money,
You don't touch
you've
it?
given away, yes.
I see.
I gave it to the British and Irish Institute of Physics,
I see.
and they are running it. They've just closed applications. They have 45 applications, and they expect to give out 6 or 7 research studentships.
They're going to do it in one lot, or is it
That's
going to be
just
annual?
this year, annual.
Oh, I
annual.
see.
They spend the interest on the money each year as the studentships.
And does the topic of research have to do with astronomy?
It has to do with physics.
Physics.
Any
physics in
bit
general.
of physics,
Yeah.
yes. Yes. So,
Yeah. So you're happy.
yeah, yes, I think they're doing a great job.
What the new generation will also have more opportunities?
I hope
in
so.
physics?
Yes, I hope so. Certainly we are getting more women coming in now, which is good.
And minorities and
Yes, well, we could do with more African people,
yes.
not so many of them. We're quite good for Asian.
Asian, you're okay now? So far?
Certainly India, Pakistan, there's plenty. I'm not sure how many Southeast Asia there are.
Yes.
I just don't know, but certainly we do quite well for Indian and Pakistani students.
Well, you have been to Thailand many times, and you have close friends with Narit people
Yes.
and Thai astronomers.
Yes.
What is your suggestion Thailand should do? Anything else that Thailand should do in physics and astronomy?
Thailand's building some very good relationships with other Southeast Asian countries.
Yes.
And I think that's very sensible, very timely. I think it will be good to have astronomy stronger
Yes.
in this part of the world.
Yes.
So I think they're doing exactly the right thing. And the other thing that's happening is next week
Yes.
there is what they call the big lift.
Yes.
They are building a radio telescope near Chiang Mai.
Yes.
And next week a big crane lifts the dish
Wow.
to put it down on its
Yes.
pedestal.
I've seen it. It's incredible.
Yeah.
Yes.
Yeah.
And to you as an astronomer, that must be really fulfilling.
Yes. Yes. No, it's amazing to see it happening. It's great.
The Narit is also talking about Thailand serving as the coordinator to
Yes.
set up an Asian sort of treaty organization.
Yes.
What do you
yes.
think of that?
Yes, well, as I say, I think if Thailand can facilitate more astronomy in Southeast Asia, that would be splendid.
This is Asia, not only South Asia.
No, it's going wider, I know.
Wider,
but
ah,
yes, yes. Yeah.
Because there's this kind of organization in Europe,
Yes,
maybe
that's right.
in other
North-
parts of the world,
North
but not in
America,
Asia
yes.
yet.
Yes. Yeah. Yeah.
People will ask you that the little green men thing now. Do you still believe that there are little green men out there with SETI project, you know, trying to catch signals
Yes.
from extraterrestrial intelligence and all this? What is your personal view on that?
Well, one of the things that's happening is we are discovering more and more planets around the stars out there.
Yes.
That area of astronomy is absolutely booming.
Booming.
So now when you look up at the night sky, you see lots of stars. You must say to yourself, there are as many planets, or indeed maybe more planets up there than stars.
Yes.
So many, many, many planets. Now, a lot of them would not be fit for life.
No.
Too hot, too cold.
Yeah.
But because there are so many, I think maybe somewhere else there is life. Whether we can make contact with it, I don't know. It might be too far away,
No.
too difficult.
Yeah.
But, you know,
But if you're an astronomer, you must always have hope.
you have hope for something you really want.
Right.
I sort of don't care if there's other life out there or not.
You don't care?
I'm not particularly worried. Yeah.
No.
But,
if it's there, it's good. If it's not there,
it's also good.
It's also good. But there are people, in the astronomy, world of astronomy, who really want to find it, right?
Yes, there are. Yes.
And that is good too, right? That they will work hard.
It's good that they work hard. I think they want to find, I think some people want to find it so as they'll be famous.
Oh, I see.
And I'm not sure that's a good motive.
No. The good motivation would be to find out the
answer.
fact.
The fact, yes. That's right, yes.
But it may take a few generations from now.
Quite possibly, yes.
Not in our lifetime.
I would be surprised if it was in our lifetime. You never know, but I would be surprised.
But it's always surprises in this world.
Yes, astronomy's given us a lot of surprises during my lifetime, so, never say no.
Never say never. Huh? Never say no.
Never say never, yes.
Thank you very much, Jocelin, for
you.
talking to me.
Thank you.